Now we are going to see the adapted design pattern practical implementation using some use case. In the previous video, I would have covered the adapted design pattern theory, principles, real life examples and etc. If you haven't watched that video, please go and watch that video and then come to this video for better understanding purposes. So here what we are trying to take is, we are trying to take an use case using real life example. So we will try to implement that real life problem using adapter implementation using Java. So the real life use cases, if suppose if you are residing in India, then your home would homes in India would receive 240 voltage as a default voltage from the electric board. If suppose our mobile battery needs just 3 voltage, if we send 240 voltage to our mobile battery, then that mobile battery would explode. So that mobile battery requirement is only 3 voltage, but we have only 240 voltage in our socket. What we are trying to do is, we are trying to create an adapter. Here mobile charger is acting as an adapter that would convert 240 voltage to 3 voltage. If some other electrical equipment needs 12 voltage, means we can use the adapter to convert 240 voltage to 12 voltage. Here that mobile charger is acting as an adapter. We are trying to implement that use case using Java. So this is the voltage. So this is a voltage class. In voltage class, there would be some voltage variable that would hold the voltage, and then socket class. This would return the actual voltage. In India, the default voltage is 240 voltage. This is the socket adapter interface. This socket adapter interface would have is containing this socket adapter interface containing get 240 voltage, get 12 voltage, get 3 voltage abstract methods. Socket adapter implementation class implementing socket adapter, and then it's extending socket. So extending socket means this method can be accessed in this class. Here, since it's implementing socket adapter interface, we need to override these 3 methods in this class: get 240 voltage, get 12 voltage and get 3 voltage. Here we have created an object for socket class sock. Using this sock, we can get the actual voltage, which is 240. So suppose if the client is asking get 240 voltage, then we can return the actual voltage by using this object. So sock.getVoltage, it would return the actual voltage 240. If our client is asking get 12 voltage, then first we need to get the actual voltage using this object, which is 240, and then we need to convert this 240 to 12. 240 by 12. Using this method, we can convert the 240 voltage to 12 voltage. In this method, we are trying to send 240 voltage, 240 and then by 20, which means 12 voltage would be returned using this overridden method. And then get 3 voltage method would do the similar process. Here it would get the actual voltage from socket object, and then it will try to convert that actual voltage to 3 voltage, 240 by 80, which means 3 voltage. We are using this socket adapter implementation in our adapter demo class. So we are trying to create an object for socket adapter implementation. Using that object, we are trying to access the get 12 voltage method, get 3 voltage method, and then get 240 voltage method. If we execute this program, you could get more details. Since in the first case we are trying to get 12 voltage, we are trying to access get 12 voltage method, so it's printing 12 voltage. And the second scenario, we are trying to invoke get 3 voltage method, so it's printing 3 voltage. In the third scenario, we are trying to invoke get 240 voltage method, so it's printing 240 voltage. So this is one of the simple or sample implementation of adapter design pattern in real life using some real life example. So if you have any other doubts, you could post those doubts in the comment section. I will try to explain whenever I get